Question 12. Three identical lamps, L1, L2, and L3 are connected as shown in the following diagram. So we've got it like this. They're all identical lamps, so we have it like that. We would have obviously a current going through all three of them would be the same. The resistances would all be the same generally, and you'd expect the same brightness. Now, when switch S is closed, what would be the situation? Well, let's just think about it. If you close switch S there, now when the current is coming through here, it can either go in that direction there through the lamp, or it can go through this. But this is just a wire. There is no resistance. So most of the current, the vast majority of current, will actually go in that route over there. You won't have any current or any meaningful amount of current that will actually go through the light bulb. So we're going to have, therefore, a lowering of the resistance of the circuit. This lamp, L2, is going to go out. This one will go out because there will be no current going through it. Now, your resistance, because if this is R1, R2, and R3, this has got a certain voltage. Now, the current, which is I, is equal to V over R, like that. Now, because your resistance when you have put this switch in is actually going to drop, this resistance is actually going to go down. Your potential difference is still remaining the same. So your current will go up. Your current is going to increase. So you're going to get a larger current. The current will actually become bigger, and therefore the V across each of these, which is I times R, I times R2, I times R1, these are both the same, the R1. This is actually going to become bigger, so you're going to get a bigger energy drop as you're going to go through. So these light bulbs L1 and L2 are actually going to burn brighter. They will be brighter. This one will switch off. So let's have a look and see. We're going to get, got so much writing here, let's just get rid of that. We're going to get L1 and L3 will brighten, and L2 goes out. So A would be correct. Going on to 13. We now have two resistors are connected in parallel and have the currents I1 and I2 as shown in the diagram. The effective resistance of the circuit in R then is given by the following amount. Now, we don't really have to worry about this I1 and I2. We can just work out our effective resistance by using our formula over here. So we're going to get 1 over R, which is our total resistance. Our effective resistance is equal to 1 over R1 plus 1 over R2. Now the way it's written here is simplified. So I'm going to simplify common denominator of R1, R2. That will be R2 plus R1 is equal to 1 over R total. And then I invert both sides. So I'm going to get R total is equal to R1, R2 over R2 plus R1. So which one would that be? It would be this over here. This one over here. That would be the correct one. I would prefer it if they had put brackets around that, like that. That would have been better. But that should be the correct one.